Alright, so last video, and I'm sure you're ready to pull your hair out, but stick with it. Chapter 6 is the most important chapter in this. If you can get this down, you're going to do great on the midterm. You're going to do great on the final. The last two chapters that are included in the final are really just an extension of this. If you understand this, you really understand Stat210. So I really encourage you to stick with it and figure this bit stuff out. So use standard normal distribution table to find little z or the z-score such that the statements are true below. So in these situations, I'll give you a probability, and I give you a probability statement, and we have to find the z-score such that the statement is true. Okay, so probability that find the z-score such that the probability less than that z-score equals 50%. Let's go to our graph. Here's our normal distribution, standard normal graph. We want to find the z-score, so which value right here, if I take all the probability to the left of that value, will equal 50%. Well, we know that is 0. Same is true for greater than 50%. Just asking for the white region in that graph now. Alright, so what is the z-score such that a standard normal variable being less than that z-score has a probability of 0.9850? We simply go to our standard normal probability table, and we find the 0.985 probability. Right there. And we say, okay, what's the z-value? Because this is the probability that for your z-score, the probability, the area left of the z-score. So that's synonymous with the less than. Anyways, the z-score is 2.17. Which is, just a refresher, that represents this little z right there, the z-score. That's the z-score. Onward, probability of, if the probability is 0.0150, what is the z-score? Probability that z is less than the z-score. And there it is. Negative 2.17. So you can see the symmetry between these two z-scores. One's positive, one's just the negative of that, and you can see it because when you're looking at the the graph. Okay. You draw this graph and then you put your, well, we should just go ahead and put 0 and 1 in. And you have these two tails on the end. The first question is asking for the z-score that gives you 0.985. So that would represent like this point right here and everything to the left of it. And then on the second question is asking for the the probability is 0.015, and that just represents this like tail to the end. But in both cases, both these tails are the exact same probability, and since the z curve is symmetric, since both these tails have the same probability, the value at which it starts or ends is the same. Just the only difference is which side of the mean it's on. So you know, that's why these two are just, you know, one's the negative opposite of the other. So I'm going to skip these two, pretty easy, going down. Given x the mean, the standard deviation, find the z-score. So basically, above here, up here, we are finding the probabilities associated with a z-score or normal variable, standard normal variable being less than a certain z-score. Like in this case, the z-score is negative 1.05. Well, later on, the next section, we're going to be finding the probabilities that, you know, x is going to be less than some number. We can say like 25 for an example, and the x will follow it a different, not a standard normal distribution, but just a normal distribution with its own mean and its own variance. And in this case, let's say that if x follows a normal distribution with a mean of 25 and a variance of 4, we want to be able to answer questions like this in terms of probability, but the only way that we can do that is by converting this to something, to the setting it equal to the probability that z will be less than something, and you know, with the same probability. The problem is, you know, we calculate out these standard normal probabilities because we have a standard normal table. We don't have a table that has a mean of 25 and a variance of 4 for that kind of normal variable. We only have the standard normal table. So in order to find probabilities associated with normal random variables that are not standard normal, there is a relationship where, oh, you have this, you want to know this probability, well, there is an equivalent probability that is related to the standard normal table, and that's what we're trying to find, the z-score. And the way that you find that z-score is this equation right here. It's just z equals x minus mu, you know, divided by the standard deviation. So that's all it is, putting in the equation. So this equals parentheses x minus mu divided by the standard deviation. The only thing you have to be careful about is I don't have to give you standard deviation here. I could give you variance instead. And in that case, you just take the square root of it, you know, so the formula is the same. And, you know, we can do this and bring it over here. We see that this z-score is 0 in this case. Why? Because the x variable and the mean are the same. So anytime that the x and the mean are the same, you know, your z-score is going to be 0. Going down to a real normal distribution problem now, so something worth that you can focus on in your exam. X follows a normal distribution with the variance given below. Answer the following questions. What's the probability that x is less than 25? So we are looking for the probability that a random, that x is less than 25 when x represents a normal random variable with a mean of 25 and a standard deviation of 4. And so step 1 is to draw what we want. Okay, so let's go right here, and we have mean of 25, standard deviation of 4, and we're interested in the x values. So you draw your curve, put 25 in the center, and then you find the point that you're interested in. That's 25, and we shade all the probability that we're interested in. So I'm going to do that by just putting in, let me see, probability that it's less than 25. And now we can see that, you know, just looking right away, that this is 50%. Now the method, you know, most of the time it's not going to be straight 50%, and you know, you don't have this right there to just tell you right away. So what you would do is, once you realize, the reason why you look at the graph is to realize what area of the normal distribution you're interested in the first place, to help map it out for you. And then the next thing that you'd do is you'd say, oh, we're interested in the probability of x being less than 25. What z probability? The next thing we do is we find the z-score. So here's our z-score, and we just say that's going to be equal to x is 25 minus the mean divided by the standard deviation. There's our z-score right there. And then you say, oh, since we know that's the z-score, now all of a sudden we know that probability of x being less than 25 is equal to the probability of z being less than 0. And since this is in terms of less than, and it's in terms of standard normal, that's what this table, the probabilities tell us. So we just look up 0 in the table and realize, oh, that's 50%. Graph. Next question, what's the probability that x is less than 10? Well, first thing you want to do is draw it. So you draw your standard normal, put 25 as the mean in the center of it, and then find the x variable that we're interested in. That's 10 in this case, and shade everything to the left of it. Now you can't really, when you're drawing this by yourself, you don't really know where this 10 is. Only thing you know is that a bell-shaped curve and what's in the center of it. So you're not going to draw exactly where 10's at. Instead, where I would draw it, not knowing these labels right here, I'd probably put it about right there. And then I shade the area left of it. What's important is that I realize what part of the bell curve that I'm trying to find the probability of. So, there's a probability. I understand what's going on now. I drew it. So let's find the z-score. Next up is find the z-score. So z is going to be 10 minus the mean right here. And that's going to be in parentheses. Divide that by the standard deviation. And, this is the z-score, or little z. Boom, negative 3.75. So now we can say, oh, we know what the z-score is. Thus, the probability of x being less than 10 is going to be equal to the probability of x, or z, being less than negative 3.75. And what's important in this equation is to realize is this z-score is just associated with this x. The direction of the probability, and that doesn't matter. So if instead we were doing greater than, probability that x is greater than 10, you find the z-score, and then you just plug that z-score, you change the x to a standard normal, and then you change whatever x value you'd be interested in this case 10, to the z equivalent value. So anyways, now we know that probability of z is less than negative 3.75. We can go to our table and look up the probability for that. 3.75 right there. So it's 0, 4 zeros and a 9. There you go. And I'm going to bring this out to show. There we go. So what's the probability that x is between 23.5 and 26.5? So now we're interested in the probability that x is between those two numbers, and first thing you want to do is draw the graph. So I have to go to this guy right here. Let's make the mean 25, variance 4, and you're just making some rough lines here to kind of see what part of the graph you're interested in. So let's just say this is right, and we are interested in This is, you know, the x values that we're interested in. And so we can look at this table now and realize, oh, well, how do you find probability of normal? There's only one way that we find probability of normal in this class. That's by looking at the z table. And the z tables only tells probability for a standard normal curve, but only for the probability of everything less than a certain z-score. So you have to realize, oh, how can I break up this sector of the probability graph to be in terms of just everything to the left of different points? And you're like, okay, I need this blue line. And what you need to realize is, you know, this probability, just this blue sector, is going to be equal to the probability of everything to the right, I mean to the left of this line, which is 26.5. So everything right here, all that probability, the blue and the left-hand white tail. And then if you take this entire probability and you just subtract this left-hand part of it, then you're left with the middle sector, which is the gold that you're looking for. So, you know, just writing it out there, that's the same as the probability that x will be less than 26.5 minus the probability that x will be less than 23.5. Alright, and we'll put an equal sign in front of this guy. That way we can see the equivalency. And that's the key. The next step is to put it in terms of z-scores. So, I mean, technically, we'll just take this back here. So let's focus on this first one, 26.5. I'm just going to call it z of 26.5. I'm going to copy this formula down. Change the top part to 26.5. And there we go. You know, the z formula is the same. 26.5 minus the mean divided by the standard deviation. Now let's find z of 23.5. Same thing. Change this to a 23.5. And there's our two z values. So now we know that this is equivalent to the probability that z will be less than 0.375 minus the probability that z will be less than negative 0.375. Alright, so we can look 0.375 up in the standard normal table. Oh, geez, sorry about that. 0.375, 0.37. Now, there is no 0.375, only 0.37, 0.38, so let's just round up. Take that guy. Now we need to subtract the negative. 0.37. Let's go to the 8 number there too. You know, and there we have our answer. Now, there's also another way that you can do that that's quicker. Instead of finding the probability of both 0.375 and negative 0.375, you can look at this graph, and if it was drawn correctly, these two lines are symmetric. So you can realize that this whitetail has exactly the same probability as this whitetail. And instead of finding the probability of everything left of this point, then the probability of everything left of that point, the quicker way of doing it is saying, oh, this is the total probability. You just take the total probability and you subtract the probability of both of these tails. And you can quickly know the probability of both these tails because they're equivalent. And since they're equivalent, you only have to find the probability of one of the tails, which would be this guy, since it's that would be everything to the less than that, and that's what our table tells us. So all we have to do is find the probability of this tail, and if you multiply it by 2, then that's the probability of both these tails. So then the total probability minus probability of both these tails, will equal this blue region. And so the probability of the second tail right here, that was equal to 0.35197. So we'll just put that right there, and you can solve for the total probability the second way. Well, actually, let's move this over. You can say the total probability is going to be 1 minus 2 times this probability, the two tails. And you see a very slight difference here. Actually, it might just be, either way, it's just due to the rounding. You realize when you have this kind of table, there's a slight amount of rounding, but the answers are the same. So this second tail method is, preferred. Okay, let X represents a student's current grade in this class. You can have over 100% in this class. X follows our student's grade is represented by X follows normal distribution with, average score of this and the variance of 0.014. So what is the probability that a student has B in the class? So between 81 and 90%. So we're interested in the probability that X is between a 0.81 and 0.9. And sheesh. So first thing you want to do is draw it to get an idea of what we're looking at here. And maybe you don't have to draw it. Maybe you're figuring out by now how to do it by hand, but always good when you first learn normal to always draw it. And let's see. So the mean is 0.817, and we're interested in everything. The standard deviation is, well, what is the standard deviation? That's the first thing we should find. We have to realize that that's the square root of the variance. And since everything kind of uses the standard deviation, we want to use this, not the variance. So 0.1183. Alright. Looking at our nice scale now, we're interested in the probability of a student having between 81 and 90%. So let's try to get a little close to that. That's 0.93. That'd probably be like right there, and let's find a point to represent 0.81. There, we'll say that's 0.81 90%. So that's what we're interested in. And now the only way to figure out this problem, we can't do the two-tail approach because these two tails are different. And you also know that two tails are different because if 0.837 is the mean, we'll call 0.81 x1 and 0.9 x2. The difference from the mean for x1 you know, these aren't the same distance away from the mean. So the probability of the tails on both sides of the normal distribution are going to be different. Anyways, moving on to solving the problem. We'll just keep this x1 and x2 right here like that. Now let's find z1 and z2. And you can just put in the z-score for that. So this is going to be equal to the x value minus the mean, brackets, divided by the standard deviation. Careful for the standard deviation, not the variance. So there's z1 and there's z2, and we can plug this in right away and say now that, you know, we know what z1 and z2 is, we can just sub those z1 and z2 in for our x1 and x2 variables. So that's the probability that x is greater than negative 0.2, and I'm going to round right away, 3, and less than 0.53, 0.53. Great. And now where we go from here is we have to get, obviously, our once again, our z table only finds probability of standard normal that, there's our standard normal graph, of any point on the standard normal, but it only finds probability left of that, so only less than a certain standard normal z-score. So in order to get this probability equal to everything with just less than signs, this is going to be equal to, and I'm sorry, this shouldn't be an x, it should be a z, because it's standard normal now. And this is going to be equal to the probability that z is less than 0.53 minus the probability that z is less than negative 0.23. So at that point we just look these values up in the table, and I'm just going to put them right here and right there. So 0.53 right here. And let's find negative 0.23, 0.20, 0.21, 0.23. And let's just double check. Oh, crap. 0, 1, 2. Good thing we double checked. You gotta be kidding me. And I missed the decimal place in that. So now we can calculate out this probability. Probability that z is less than 0.53 minus probability that z is less than negative 0.23. And that is our answer. So roughly a 29% chance that a student will have a B in the class. Alright, so people can have over 100% in the class. So what's the probability that a student has over 100% in the class? Well, first thing we want to do, let's just write out what we want. Probability that x is greater than 1. So here we want to draw the standard normal. The mean has 0.837. The standard deviation is 0.1183. Now, so you draw your z curve, 0.837 is in the middle of it, and now we are interested in everything greater than 1. So find a line on here, draw your 1 to the right of 0.837, and realize and shade everything that we're interested in. So in this case, we would shade this white area, everything under the curve right there. That's the total probability that we're interested in. And now we want to say, what's this area of the white area? Well, our table doesn't find the probabilities of, the z, something to the right of a certain z-score. It only finds to the left. So we have to realize that this tail is the probability of this tail, the white sector, is going to be 1 minus the probability of the blue. So it has this same z point. So now we can realize, oh, that's going to be, this is going to be equal to the probability that of, it's going to be equal to 1 minus the probability that x will be less than 1, right? So let's find the z-score. And we want to use 1 for our x value, 1 minus the mean divided by the standard deviation. And this is our z-score right there. So now we're going to take this equation and plug our z-score into it. It's 1 minus the probability that z is less than 0.1378. And I'm just going to round up to 0.138 because that's where our table works. And that's because probability that z is less than 1.38 is the same as probability that x is less than 1. That's what the z-score tells us again. So go to our table, 1.38, 1.38 right here. So a student has an 8% chance if the grade distribution followed normal distribution and the mean was this, which is the mean for our class at the point where I got the data, and that was the variance. We're also assuming that it follows normal, which it doesn't, but maybe if I curved it, I could make it follow normal. And let's say, oh, I have 19, this is just for the side, but I have 19 students. So the number of students, the expected number of students to have over 100% in my class would be total number of students multiply the probability of any student having over 100%. Oh, so we expect 1.6 students to have over 100% of my class. That's if I get bonus. Of course I don't get bonus. And let's throw out some more decimal places in there. Alright, I'm happy with that.